Hey everyone, it's Mr. Carr again. Today we're going to be talking about 1.3 day 2. Continuing a little bit on with our continuity and limits, but we're going to be focusing today on end behavior. So you have done end behavior before, but today we're going to do it in terms of limits. So we want to use that kind of a terminology when we talk about it. So graphs that approach infinity. So we're looking at the graph here of f of x equals x to the third minus x squared minus 4x plus 4. So we're going to describe its end behavior using limits. Okay, so then support the conjecture numerically. So the idea is this. So if we look at here, we can see on the graph how it's going to go this way and this way. That's the end behavior that we want to describe. So the first thing I'm going to say is the limit, we're using this terminology, the limit as x approaches infinity and the limit as x approaches negative infinity. Okay, so this is describing this end of the graph. Okay, because that's going off to a positive infinity this way. Here, x is going to a negative infinity, so it's this part of the graph. It's going off to the left. Okay, so then the next goal is we're describing what is f of x going to equal to. Okay, so when I look at that right here, it's going up and up and up. It's going up, since it's going to go up forever, f of x is just equal to positive infinity. Here, this graph is going to go down forever. So as it goes left, f of x is going to negative infinity. Okay, so a way of looking at this is that the limits do not actually exist. There is no limit to it, but it's approaching, or you can say the limit is approaching infinity and negative infinity. Okay, so supporting the conjecture numerically, this would involve us making a table and plugging in more values. So if you were to plug in 4, what would you get? You get up here to a high number. Okay, so if I do that real quick, I can, let me pull up a table real fast here. Yeah, I'll tell you what, let me pause it real quick. I'll pull up Desmond's table for you. Okay, so we have our table here for our function. We can see roughly the graph looks. If I zoom out, you see how it keeps going on forever and ever. So we get a little bit more evidence there. But again, using the table feature, I can just start plugging in any numbers I want. So if I do this where I go 3, 4, 5, you see how the outputs are still growing. Same thing if I go with some more negative numbers. We can know -2 goes to 0. If I go -3, I can go -4. Okay, -5. You see those numbers are still going more and more negative. So what I've shown on here is that it's going like it is growing towards a positive infinity in the x positive direction, and it's going towards a negative infinity in the negative x direction. Okay, so that's our end behavior and how we describe that. Whoops, I accidentally got rid of the negative infinity symbol there. All right. So here's another example. Same thing, just look at this. It's just a matter of doing the correct notation. So as x approaches negative infinity, that's going this way here. It's going down forever. So f of x equals negative infinity. As x goes to infinity, f of x goes to a positive infinity. Okay. All right. Use this graph. So we're looking at here that graphs that approach a specific value. Use the graph of f of x equals x plus 2 over x squared minus x minus 2. Describe its end behavior using limits. Support the conjecture numerically. Okay. So same thing as before. We are going to look at like identifying in the graph what's happening here and here for my end behaviors. So I say the limit as x approaches negative infinity and the limit as x approaches infinity. So what is f of x going to in both cases here? So this one's a little bit different, and we have some other things we can do to use our to help us here. But you notice it's not approaching, it's not going down or up forever when I look at this side. It looks to be approaching something like this. Okay. So what's happening with that? Sorry, give me 1 second here. Sorry, I had to just double check one other thing. So when I look at the negative x direction, it's kind of, this one's weird because it looks like it's approaching a value that's below. So as a conjecture, I would say maybe it's approaching -1/2, but it's not actually going to do that. So again, we're going to go to a bigger graph / table to help us with that. So if I come to here, go to my good old Desmos here. Let's go ahead and make a table. In the negative direction, we can see here it's crossing at -2, 0. So if I do -3, it goes to -0.1. Whoops. We'll go to -4. Okay. Now it's going lower. Okay. It's going lower at -0.1 repeated. If I go to -5, oh, it's actually getting back towards 0. and then -6. Here I am at -4. So it actually does this very small dip. Like when you get really close, you can kind of see it's going a little dip here, and then it's coming back up to 0. As I go on, it's actually going to go back and closer to 0 again. So that means that graph is approaching 0 from the left, or approaching 0 to the left side there. If I look at the right side, it's going to do something very similar. So I'll show you on Desmos here. The numbers are getting lower and lower and lower. It's getting closer and closer to 0, but it's never going to cross 0 in this case. So it's kind of weird because I cross 0 here, it dips lower, but then it comes back and gets closer to the graph. Okay, so what's happening in both directions is as my end behaviors go on, it's approaching 0 towards the ends. They get really, really close to 0. If you remember from before, it's called a horizontal asymptote. So my limit as x approaches -infinity is that f of x is going to equal 0. My limit as x approaches infinity is that f of x will also be 0. They're going towards specific values. Okay, so that's what's happening with that kind of example there. And again, this is a small version of the graph. It's really difficult to see it right here where it's approaching 0, but it's a couple of things that we'll talk about when we talk more about rational functions, like what's happening with that horizontal asymptote. Okay, for now, use your table, use your graphing calculator. Make sure you see where that's approaching in the end. Okay, so here's just another example here. You could do that real fast. When we look at this one, kind of the multiple choice is giving it away a little bit, but we see here, horizontal asymptotes, my f of x right here is approaching that value, that y value output. Here, it's approaching the same value going that way for the end behavior. So the answer here is going to be C. As it approaches -infinity and positive infinity, they're both outputs are approaching 2/3. Okay. And then this is, that's the answer right there. All right. Well, that is it for today. Okay. So again, we're talking about our limits and how they use for end behaviors, trying to describe and when it approaches either infinities or negative infinities, or they approach certain values. Okay. And that has to do with our horizontal asymptotes when it comes to like a lot of our rational functions. All right. That's it for today. Take care, everybody.